All right, this is part 3. You guys, I am so sorry. This has happened a lot with my AP class, because in my AP classes I have to make really, all of their videos are like 45 minutes long. There's a lot of stuff, and a lot of times what happens is I will the video just keeps cutting off because it's getting full so quick, and I don't know, this time I guess because of the holidays, or I don't know what it was, but it just kept cutting off. All right, so what I'm going to do here, it's circular motion, and you'll work problem number 1, 2, and 3. I told you in a moment when you do it. But what I'll do is this. Here's what I said when it was cutting off last time. That the circumference, 2 pi r, okay, that's the radius, and the radius is like the length of the string. Well, if you're talking about a ball on a string or whatever, if it were like the Earth around the sun, the radius, well, that doesn't work. The radius would be just how far you are from the sun. Actually, it would be the average distance, because you might also know that it's not a perfect circle. We'll get to that later. I'm jumping ahead a lot. This, I said, velocity. The velocity as it moves around is equal to 2 pi r divided by the period. And I did talk about, I think I was telling you that when it cut off last time. Period is the amount of time it takes to make one complete revolution, one circle all the way around. We're talking about the Earth around the sun, it takes 365 days for the Earth to go one time around the sun. But now when you calculate it, when you're doing a math calculation, you have to put it in seconds. So the period is the time in seconds. That's what I had up there. Period is the time in seconds to make one circle, or you can say orbit if you're talking about planetary motion. But see, we're not just doing planetary motion. We're also talking about, like, if someone runs around a track, in a circle around a track. If it were an oval track, like track in the sport, then you would just take the average radius there. Okay. Let me see. So, what other equation? All right, here's another equation. AC, centripetal acceleration, is equal to v squared over the radius. And radius will be in meters. Velocity will be in meter per second. Now, this is one that I was showing you how they derive it on the page before, and you're not going to have to be able to do that. Don't worry. And then there's another one. You can also find acceleration by 4 pi squared r divided by the period squared. So that you could actually figure that out by substituting this stuff in here, and you'd end up getting that. But oh well. So all right, there are the equations. So now this will become more familiar, like what you've seen last semester, kinematics, problem solving. All right, so I'll start off with letter A. It says a 1.50, and I'm on 70-B, where these are the equations. This is the big stuff. Everything, the video kept cutting off, but everything I did before now was like an intro and kind of give you the concepts of it. I guess you got it kind of put together in pieces there, but okay. A 1.50 meter long rope is tied to a weight. A boy spins it around, whirling the weight around a horizontal circle in 1.20 seconds. So he's like spinning it around his head, maybe like a slingshot. So you can even draw it that way. You could draw a picture like that and say that's the circle. But of course, it's more like if you were on top looking down, this will be the circle. Let's just draw the circle. Here's the weight. He's spinning it above his head. We'll say, get away from that guy. Okay. It didn't tell you that what the weight of the weight was, but it says it takes in a circle in 1.20 seconds. So they're giving you 1.20 seconds. That would be the capital T, the period. Because the reason why you know it's a period is because it says in a circle in that much time. The rope that's tied to it is 1.50 meters. That's pretty long. I mean, my little boy, he's only 7, but man, if he had a rope out there with a weight, I'd back up a long way. Okay. All right, so anyway, that's 1.50 meters. What does that represent? the period is 1.20 seconds. 1.50 meters must be the... Well, let's look at all the equations and see which one of these has meters. Pi doesn't. Period doesn't. So it must be that one, the radius. The radius is in meters. All right. Okay. So now, what did they ask you to find? Let me go back to that. A 1.50 meter long rope is tied to a weight. Boy spins in a circle. What distance does it travel as it spins? So that's the first question. What distance? So, as it spins around, what is the circumference? That's what they want there. So, for number 1, circumference is 2 pi r. 2 times pi. On your calculator, there's a button, 3.14. I mean, there's a button that says pi, give a scientific calculator, and you can just push that button right down there. There it is. Or you can put in 3.14 if you want to. And the radius is 1.50 meters. So, 2 times pi, I'll use my calculator, 1 times 1.50 is 9.42 meters. So it's 9.42. That will be the path, well, in the air that's traveling around that circle, all around it, the perimeter, or we don't call it perimeter, but the circumference, the distance around it will be 9.42 meters. Then, 2 says, what is the velocity of the rock as it travels around? Well, now, you could say also this, and this might come up on a later problem. I'll just see. I'll just jump in now. Remember, velocity is like meters per second. So I know how many meters it went, then divided by how many seconds does it take to go all the way around, and we already got that as 1.20 seconds. So you just divide those two. You can just take that divided by that. That will give you the answer. But now, if you want to use this equation, this gives you the same thing. V equals 2 pi r over the period. And we already know 2 pi r is 9.42. I mean, if you want to plug them in again, you could. 9.42 meters over the period, 1.20 seconds. So 9.42 divided by 1.20, 7.85 meter per second would be the well, we gotta call it velocity. Yeah, will be the velocity. Yeah, I'll just say velocity. I was about to say centripetal velocity. I never hear about that. They just say velocity. Centripetal acceleration, they'll talk about that. In fact, yeah, that's the next question. What is the centripetal acceleration? The word centripetal means the acceleration toward the center. Toward the center. I'm going to talk more about that in the next lesson. But centripetal acceleration. So, centripetal acceleration is v squared over r, or it's 4 pi squared r over period squared. It says they do it in 2 methods. I'll just use this method. You can also use that one. There will be times later on down the line where it helps you to use that equation. But in this particular equation, you can just use this, v squared over r. So AC is v squared. V squared is 7.85. We just got that. Don't forget it's squared. And the radius was 9.42. And so, you might say, well, there's no time in that. Well, there is time. It's included in the velocity. Okay, so 7.85. To make sure you square it, then divide by 9.42, and you get 6.54 meters per second squared. Now, that's called the centripetal acceleration. And I'll just say that, well, we'll get into it later on in the next chapter. But if you've been to like an amusement park and you ride around a ride that spins you and all that, you feel a force on you. Or even when you drive in a car and you come around a circle, you feel there's a force, an acceleration on you as well. And it's toward the center of what you're doing. It's real strange. It feels like it's otherwise, but it actually is pulling you toward the center. Kind of a strange thing. And we'll get to that later on. Okay. All right, what's the next question? This one talks about the moon has a period of 27.3 days. Okay. And is a distance of 3.90 10 to the 8 meters from the center of the Earth. Assuming the moon has a circular orbit around the Earth, calculate the time in seconds it takes for the moon to circle the Earth. Okay, because we're going to have that in seconds. So it says 27.3 days is how long it takes for the moon to go one time around the Earth. I want to change that into seconds. So from days, I'll go to hours. 1 day is 24 hours. And 1 hour, you should know this anyway. Well, hour is actually H, not HR. 3,600 seconds. Very good for physics students to know that. I mean, you can go from hour to 60 minutes, then one minute to 60 seconds. 60 times 60 is 3,600. But it's better just to know that 1 hour is 3,600. If you get bored in a college class the last 2 or 3 hours, you can say, hey, I'm going to count to 3,600, and that will be 1 hour later. 1, 2, 3. And when you get to 3,600, you'll get 1 hour will have passed. Isn't that exciting? Okay, so here we go. All right, 27.3 times 24 hours times 3,600 gives you, oh my goodness, it's a very large number. I'm going to do scientific notation with 3 sig figs. I get that on the calculator. So 2.36 times 10 to the 1, 2, 3, 4, 5, 10 to the 6. Looks like. Yeah, 10 to the 6 seconds. Why do I need it in seconds? Because in the next question, they're going to probably ask you, calculate centripetal acceleration of the moon as it orbits Earth. Centripetal acceleration is v squared over r. Now, I don't have the velocity on this one, but that's why I'm going to use, so I would want to use the other equation. Now, you could try to find out the velocity, but it's pretty much going to be, I mean, you could go here and do all that way, but I'll just go to that equation. It's 4 pi squared r over the period equals 4. Now, don't forget pi has to be squared. I know because you always hear pi r squared, pi r squared. You hear that so much. Make sure you remember in this equation it's pi squared r. Okay? R is the distance from the moon to the Earth, the average distance. And they gave that in meters, I think, didn't they? 3.90 10 to the 8 meters. And then the period we just found was 2.36 10 to the 6 seconds. All right. So let me calculate all this. 3.14 squared times 3.90 10 to the 8th times 4 divided by 2.36 10 to the 6 equals. Okay, it is 65. I'll do 3 sig figs. 6520 meter per second squared. That is a very large acceleration. And that is going to be correct, I believe, because the Earth gravity pull on the moon is so great. Oh, wait, did I do the math? Wait, let me make sure I do my math right. 3.14 squared times 3.90 10 to the 8th times 4 divided by 2.36 10 to the 6. Yeah, that's correct. All right, so that's a much higher acceleration than what you saw earlier. Okay. And then it says, what is the velocity of the moon in meter per second as the moon circles the Earth? The velocity, okay, in meters per second. So I'll have to use this equation up here. And I'll have to erase it to give you some space. So, velocity is 2 pi r over the period. So 2 pi r is 2 times 3.14 times that same 3.90 10 to the 8th. Make sure I didn't put the wrong number there, okay? And the period now is still the same, 236 10 to the 6 seconds. And that will give me the velocity 2 times 3.14 times 3.90 10 to the 8th divided by 2.36 10 to the 6. So you get 1040 meter per second And you know what? That's over 2,000 miles per hour. That's how fast the moon is moving. You know, it's just it's so far away that we don't notice that, but it's moving 2,000 miles per hour. Wow. Okay. If you change it to mile per hour, you can do that. All right. And there's one more problem here. And well, I'll erase the equations, but I'll be okay with it, I hope. This is about a roller coaster. Now it says C. Well, this is still 7OB, but this is problem C. A roller coaster is racing downward on the track at 30 meters per second. Suddenly it comes to an upside down vertical loop. So you have a roller coaster, you come down, and you have a loop. All right. Now it says the roller coaster completes the loop in 8 seconds. That tells me, all right, so we're talking about the loop right here. It completes the loop in 8 seconds. The time, so that's the period to go around the loop one time. And it says, what is the height of the loop? Well, what's the height of the loop? How can you figure that out? Okay, well, notice this. This is the radius I drew. I just drew that in there. The height would be double the radius, right? All the way there to the top. How can I find the radius? Well, it said 30 meters per second was its velocity. A lot of times I have to have the equations right in front of me and I erase them off the board. But so let's look at the simple. There's 2 equations to look at. There's AC equals V squared over R. And there's also V equals 2 pi R over the period. Now, I've got the velocity. I've got the period. So I can find the radius with this equation right here. So that's what I'll do. So number 1, the height of the loop. "30 meters per second equals 2 times 3.14 times, we don't know the radius, but we know that the period is 8 seconds. Okay. So, let's just solve for R. So 30 times 8 divided by 2 divided by 3.14 give me a radius of 38 meters. Wow, that's really high. 38 meters equals R. Sounds like Magic Mountain. Okay, so 30 times 8 divided by 2 and divided by 3.14, and double check it. 38.2, I said 30.2, I don't want to write 38.2 meters is the radius. Now that's the radius, so the height would have to be double the radius. So that's the radius and that's the radius. Will be 2 times R. 2 times 38.2. So 76.4 meters. All right. So let me write that down. Radius equals 38.2. And of course, height will be 76.4. All right. Now, because I have to erase that, that's why I want to write it down. 2, calculate the centripetal acceleration of the roller coaster. All right, so what's the acceleration? Like I said, as you're moving around, because of the curved track, you're hitting the track. The track is keeping you, pushing you, and keeping you in a circular motion. It's accelerating you. It's putting a force on you. We're going to talk about that in the next lesson. But okay, but what is the acceleration? Well, that looks like I can use this one now. Yeah, AC is V squared over R. That's a simple one. Just don't forget to square the velocity. 30 squared over the radius, 38.2. I'm glad I wrote that down. I was thinking it might come back. All right, 30 squared divided by 38.2. 23.6 meter per second squared. So that's a big acceleration. Okay, think about that. Remember, when you fall to the Earth, the acceleration is 9.81. I should have told you about that on the other one. We saw the moon a moment ago. So 9.81 is when you fall to the Earth, okay? Well, the acceleration here, 23.6. So actually, that's going to be the next question. How many G's of acceleration does this represent? Now, this is something that is more of a trivial knowledge, but actually I wouldn't say trivial. You need to know it for this chapter. A G is equal to 9.81 meter per second squared. So, how many G's is 23.6? All you're doing is you're going to say 23.6 divided by 9.81. And why are we doing that? You'll see here. 23.6 divided by 9.81 equals 2.4. 2.4. So it's 2.4 G's. So that means 2.4 times what gravity puts on you. So, you know, when you're on a roller coaster, you go on a loop like that, you feel this heaviness pushing on you. I'll say this. Here's an interesting thing. If you're falling, like when you jump off the diving board or a high dive, you know, you feel yourself getting faster. You're pulled by gravity. You feel that. You're feeling 1 G of G. They call it G force, but you're feeling 1 G of acceleration as the Earth's gravity pulls you down. Well, on the roller coaster, you're feeling more than that, 2.5 times. Probably that's more like how it would feel on Jupiter. Like if you were falling on Jupiter, you would be feeling it much more gravity. Okay. Well, anyway, so I said on this to do number 1, 2, and 3. And I don't know if I know I was thinking, should I make you or tell you to do number 4 also? No, I guess number 4 is kind of crazy, but it's not. I don't know. You could try if you wanted to, but I might later. All right, that's all. Finally, part 3. We got this video done and didn't cut off this time. All right, I'll see you.